All right, guys, this is another popular question from several students. Most of the people that asked about this asked to go about letter B, which means that just some more practice with the expected gain or the expected value, right? So that's what we're going to look at here, okay? Just like in the past examples, the one of the first things that we're going to do here is we are going to create a probability distribution table. All right, so it does say that there's a bunch of lottery tickets. One ticket wins a prize of 5,000. 5 tickets each win 1,000, and 10 tickets each win 200. All right, so let's go ahead and make our probability table here. All right. Now, what we're interested in here is the value of the ticket. So that's what X is. X is the value of your ticket. So you have a $5,000 ticket. You have a $1,000 ticket. You have a $200 ticket. And then you have a tickets that are worth nothing, right? Now, how many total tickets are there? Well, there are 10,000 tickets, right? So given that there are 10,000 tickets, okay, how many are worth $5,000? Just one, right? So the probability that X is going to equal this specific X value is 1 out of 10,000. All right. Now, 1,000, there are 5 $1,000 tickets. So that means that this is 5 out of 10,000, right? That are worth $1,000. And then there are 10 tickets that are $200. So that would be 10 out of 10,000. Oops, that's an extra zero there. That's all right. Okay, now the question is, how many are worth nothing then? Well, there's still 10,000 tickets, right? 10, 15, 16 of them give you money. So that means we're going to subtract 16 here, and we're going to get 9,984. So 9,984 are worth nothing. All right? So the probability of winning each prize, there you go. 1 out of 10,000, 5 out of 10,000, 10 out of 10,000, and 9,984 out of 10,000. Now, obviously, some of these can be reduced, right? This could be reduced. This could be reduced. This could be reduced. And you're welcome to reduce those. I believe that the answers in the back of the book probably have those reduced, okay? So you can go ahead and do that. I'm not going to do it right now because I believe that you are capable of reducing fractions. We're going to go on to letter B, which is where the questions tend to lie. Okay, so this is the expected gain for one ticket. Now, the expected gain is just the same thing as saying what is the expected value of that ticket. And if you've watched any of the other videos, we go through this process of you take the value and you multiply it by its probability. So we just take the value of 5,000, and 1 out of 10,000 people will get that $5,000. And then we take that value of 1,000, and 5 out of 10,000 will get that. And then we add on the 200 times 10 over 10,000. And then at the end, we've got 0 times 9,984 times over 10,000, right? And so just like we've done in the past, you take the top value, multiply it by its probability, add that to the next value times its probability, and so on and so forth until we get to the end. Now, of course, anytime you multiply by 0, you're getting 0, so that's going to cancel out. Again, you'll notice that I left it in the denominator of 10,000 because that's going to be helpful here. When I multiply this, this is going to be 5,000 over 10,000 plus another 5,000 over 10,000, right? Because I'm just multiplying 1,000 times 5, plus 200 times 10 would be another 2,000 over 10,000. And so therefore we add those all up and we get 12,000 over 10,000. Or in other words, you divide those two and you get about 1.2 not about. You get exactly 120. Okay, so that's the expected gain. If I buy a ticket, on average, I'm going to win 1.20, right? Now, this is a situation, we talked about different measures of central tendency before, right? Mean, median, and mode. Well, your mean average is $1.20, right? Well, that's not your mode or your median. Your mode and your median are both zero. Zero is a better representation of what the average person is going to get, right? Most people are getting nothing, right? 16 out of those 10,000 are going to get a significant amount of money. The rest are not. 9,984 get nothing, right? This is the expected gain of one ticket, though, right? If we average everything out, we do our expected value, this is what we get. Okay, letter C says the price of a ticket to make the lottery a fair game. Well, if you want to make it fair, then you need to pay $1.20 for a ticket, right? If you pay $1.20 for a ticket and then you expect to get $1.20 for a ticket, then on average it will balance out. Okay. Now, that's not how the lottery works, right? The point of the lottery is to make money for some reason. So this is not answering the question anymore. I'm done answering the question. But I do want to bring this idea up is that, they say, well, 50% of the money we make is going to go to the players. The other 50%, half of the money is supposed to go to this charity or this other organization or to government spending or whatever it is. Half of the money goes to that other scenario, right? So in that situation, if you want half of your money to be able to go to that, then you actually are going to double the cost. And so your lottery ticket might cost $2.40 because on average, they're going to have to pay out $1.20, which means that there's $1.20 left over for them to do whatever the heck they want with it or whatever they're supposed to do with it. All right, so that's how lotteries work. And that's how governments and other charitable organizations can make money off of it because they're charging more for the tickets than what they're actually paying out. All right. Okay, that's the end of that question. Hopefully that's helpful. Hopefully by now you're getting the idea of expected values and the probability distribution tables, and having more examples is being helpful to you. All right, that's it.